Hey everybody, here's your lesson for number 11. Please make sure you're caught up on all of the videos. Go back through and make sure your packet is complete and that you are complete all the way up till lesson number 11. Alright, today's lesson is on graphing linear equalities and two variables. So when we talk about is each ordered pair a solution to the inequality, we know a solution is going to be a value for the variable that makes the equation true. So we're looking for a solution which is that value for the variable that makes the equation true. So when we have an inequality, meaning greater than, less than, greater than or equal to, or less than or equal to, we recognize that there's more than one that's going to make it true. So when I talk about this equation, if I'm substituting in 0 for x plus 0 for y, if I'm testing to see if this works, I have to say, is 0 bigger than negative 3? And yes, that is true. So yes, that one is a solution to that inequality. All right, my second ordered pair, my 6 and my 3, if I put negative 6 and I put positive 3, is that going to be greater than negative 3? Well, is negative 3 bigger than negative 3? Yeah, no, that's not true. It's equal to, which means this one is not. So this one's a yes, and that one's a no. Check out our second one. I have 2x plus 5y. So for my first ordered pair, I'll go ahead and I'll put my 1 in for my x, my 2 in for my y, and I'll see if this is greater than or equal to 10. Remember, the alligator eats the bigger one, and we want to make sure that what is on this side of the inequality is bigger than that. So 2 plus 10 is greater than or equal to 10. Is 12 greater than or equal to 10? Yes. So that one is true. Let's check out our second one. 2 times 6 plus 5 times 1, which is our value for y. Is that greater than or equal to 10? Is 12 plus 5 bigger than or equal to 10? Is 17 greater than or equal to 10? Yes, this is also true. Alright, so today we're going to be graphing inequalities in two variables. So when we graph inequalities in two variables, the first thing we're going to do is write our equation in slope-intercept form. Then we're going to graph the line by plotting the y-intercept and doing the slope, our rise, and then our run. So first of all, we need to understand what kind of equations we're looking at. Okay? If we have an equal sign, we always graph using a solid line because it's allowed to be equal to it. If I have a less than sign, that means that I'm going to graph that using a dotted line because it's not allowed to be equal to. It's not allowed to be equal to, and that line in a graph represents everything that it is equal to. Here I have a less than or equal to, so that means I am going to have my dotted line because it is allowed to be equal to it. If I have a greater than, I'm back to that dotted line, because for the same reason, that value is not equal to, and that line is a picture of my solutions, so I can't have it filled in. So this is greater than or equal to, which means I'm back to my solid line. Okay. So here's what we're going to do. Once we graph it, we're going to pick a test point, and we're going to determine if it's part of the solution. If it's yes, then you are going to shade the side that includes a test point. If it's no, you're going to shade the other side from the test point. And that'll make more sense once you see me do it. Okay, solve and graph the inequality. So we'll go ahead and take a look at this first one. I'll subtract 3 from each side, and that's going to give me all the values of x are bigger than -5. Now here we go, right out of the gate we have a VUX. I know it's a VUX because I have just an x here. So that means -1, 2, 3, 4, oops, wrong way, -1, 2, 3, 4, 5. This x value is going to be the starting point of every single value on this line. Let's go back to our inequality. All the values of x are bigger. Say that. All of the values of x are bigger. The alligator's eating the x. So all the values of x are bigger than -5, which means that every single equation that makes this true is on this side of this dotted line. And hey, this line is dotted because it's not allowed to be equal to. Okay, so then we can shade this side of the inequality. All right, identify 2 points that are solutions. Any xy ordered pair that has an x value bigger than -5. So I can say 0, 7. I can say bigger than -5 is -4, I don't know, 20, whatever you want. Okay. -3x is greater than or equal to +15. Divide by -3, divide by -3. Uh-oh, that's an inequality. I divided by a negative, which means all the values of x are smaller than or equal to -5. So here we are again, another VUX. No y's in the equation, just x's. I come back out to -5, 1, 2, 3, 4, 5. But this time, instead of a dotted line, I'm going to draw a straight line because guess what? It's allowed to be equal to it. This line here means that this as a -5 is okay. But now I have all my values of x are smaller than, so everything on this side of this line is a possible solution. So anything with an x value that is smaller than -5, and then any y will do, is a solution. All right, let's take a look at this last equation. I had 2 VUXs because just x's. Guess what? This one has just a y, so I'm looking at a hoy. When I go ahead and I solve for that y, I divide it by a negative, so when I flip that sign, that means that all the values of y are greater than is going to flip to smaller than. 8 divided by -4 is -2. It's not allowed to be equal to it. So when I go to my output line of -2, I'm going to draw a dotted line, and all of my y values are going to be smaller than or less than that line. Whatever I do ordered pairwise, I have to make sure that this y value is smaller than -2. So I can say -3, I can say -10, and any old x will do. That doesn't matter. All right, let's take a look at the next page. So some more graphing. So we'll go ahead and we have, again, another hoy. So when I add 6 to each side, I get all the values of y are going to be bigger than +1. So I have a dotted line because it's not allowed to be equal to it. All my values of y are bigger. So when I go ahead and I identify 2 points that are solutions, I don't know any 2 points that exist out here. So as long as my y value is bigger than 1, here I have a y value of 2, here I have a y value of 3, and any old x will do. So if I have a y, an x, a positive or a negative, it doesn't matter. All right, so we had 2 hoys, 2 vexes. Now we're going to have a line with a slope and an intercept. This is a fast and easy one to graph. My intercept of 4, 1, 2, 3, 4, and my slope of positive 2, rise 2, 1, 2, run 1, rise 2, run 1. So that's a nice easy line for me to draw. I'm going to draw it as a solid line because it's allowed to be equal. So here's how it was easy with the horizontal vertical lines to know where to color. But with this graph, what I'm going to use is a test point. And 0, 0 is the easiest test point. So if I substitute 0 in for y and I test to see if that gives me a true solution, is 0 greater than or equal to positive 4? No. So that means I'm going to color the side of this line where my test point is not, because it did not make it true. All right, let's check out the next one. I have a less than sign, so I know right away I'm going to have a dotted line. My y-intercept is -1, and I'm going to fall at a rate of 1, 2, 3, 4, 3 for every 1, 2, 3, 4 I go over. Fall at a rate of 1, 2, 3 for every 1, 2, 3, 4 I go over, because my slope is -3/4. Now I got to remember it's a dotted line, so dot, 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 dot. It's not allowed to be equal to it. When I look at 0, 0, I can use that as a test point. Is 0 smaller than -3/4 times 0 minus 1? I can pick any point. I choose to pick 0, 0 because look how easy the math is. Is 0 smaller than -1? Because that cancels out. No, that's not true. So again, I'm going to shade opposite of where my test point was because my test point did not make it true. This graph represents a picture of all the solutions. Every xy ordered pair that makes this equation true is sitting in that colored area. All right, let's zip through these next 3. We'll go ahead and we'll solve for y. So we'll say we'll subtract 3x from each side. The opposite of y is greater than or equal to -3x minus 5. Divide by -1. And you know that's going to switch my sign. So y is smaller than or equal to positive 3x plus 5. 1, 2, 3, 4, 5. There's my y-intercept. 0 in, 5 out. And rise at a rate of 1, 2, 3, 1. When I go to draw this line, it's going to be a solid line because it's allowed to be equal to it. So here's my solid line. And I'll pick 0, 0 again as my test point. Tell me about, is 0 smaller than or equal to 3 times 0 plus 5? Is 0 smaller than or equal to 5? Yes, that's true. So that means that I'm going to go ahead and color on the same side of the line where 0, 0 is a solution. We'll go ahead and subtract x from each side. 6y is smaller than or equal to the opposite of x, minus 12. Divide by 6. Y is less than or equal to -1/6 x minus 2. Here's my y-intercept down here at -2. And my slope is fall 1, run 1, 2, 3, 4, 5, 6. I'm allowed to be equal to, so I'm going to go ahead and draw. That's a very flat slope, isn't it? I'll draw my line. I love using 0, 0 as a test point because 0, 0 makes the math easy. How does 0 compare to negative 1/6 times 0 minus 2? Is 0 smaller than or equal to negative 2? No, that's not true. So that means that I'm going to shade in the part of the graph that does not have 0, 0. Negative 2x minus 3y is greater than or equal to positive 6. I'm going to go ahead and add 2x to each side. Negative 3y is greater than or equal to 2x plus 6. Divide by negative 3, divide by negative 3, divide by negative 3, switch my sign. My y value is going to be smaller than or equal to negative 2/3 x minus 2. Come down to negative 2. Negative 2/3 is drop 2, run 1, 2, 3. Drop 2, run 1, 2, 3. So when I go back to my sign, yes, it's allowed to be equal to it, which means I'm drawing a solid line. We'll go ahead and pick 0, 0 as a test point. How does 0 compare to negative 2/3 times 0 minus 2? Is 0 smaller than negative 2? Nope, not true. So that means that, again, we're going to go ahead and color the side of the graph that does not have 0, 0. All right, now the fun part. You are going to be able to use Desmos for some of the inequality graphs on the test. It's also helpful to check your homework, but you'll need to be able to graph these without it too. So here's the site that you go to for Desmos, and you're going to type in the inequality. And when you find the keyboard setting, you can see where you have your inequality keys. And you can test each of these out. So your parents gave you $75 to spend on some new clothes. Jeans are on sale for $25 each, and sweaters are on sale for $15 each. Let X represent the number of jeans you buy, and Y represent the number of sweaters you buy. All right, ready? Let's see. So X represents my number of jeans, and I know that Y represents my number of sweaters. Write and graph an inequality that shows you what you can buy. So when I have $75, that means that $25 for every X plus $15 for every Y has to be less than or equal to $75 because that's all the money I have. So what I want you to do is enter this equation into Desmos, and I want you to tell me what you see. Okay, so we're going to try this. Here I am at the Desmos website, so I'll go ahead and do that. When I come up in here, I'm going to go ahead and type my equation, 25x plus 15y. And remember, I want to have it be less than or equal to, so I'll come down here and open this up, and I want my less than or equal to 75. So I don't know if you can see that or not, and if I want to, I can play with my parameters. I can zoom in or out, and I can slide my graph so that I can see what I'm able to purchase with my jeans. So why don't we blow it up a little bit and bring it over here, because I don't really have a whole lot of money to spend on anything. when I look here, I can see that with my $75, I can afford 3 whole pairs of jeans alone. Or I can go up here and I can afford 5 whole sweaters alone. And every single point that exists between the axes, remember we want to keep in mind, here's our x-axis, or here's our y-axis, and here's our x-axis. So everything on this side of the axis is not going to be possible. But everything over here, these are all different possible combinations of my sweaters and jeans that I can buy. All right, make sure you do your homework. I'll check in with you later.